Hello, friends. Welcome to Science Talk. I'm your host and resident oceanographer, Jim Massa. Want to discuss with you this article that was just recently published in the journal Climate Dynamics. And only have the abstract here. If you want to look at the entire article, cough up $40. I don't have $40 to cough up right now, so we'll just look at the abstract, but the abstract shares with us some important information, and that's what I wish to share with you. So the title is Impacts of Arctic Sea Ice Loss on Global Ocean Circulations and Interbasin Ocean Heat Exchanges. Okay. So it says just when you scroll down here, it's loads of citations, references, etc. So the Arctic sea ice loss during the past several decades plays an important role in driving global climate change. Herein, we explore the effects of Arctic sea ice loss on global ocean circulations and ocean heat redistribution. Right? Key word there. Not just distribution, but redistribution, implying that it is changing. Remember, the oceans are really the major driver of climate. Yes, the atmosphere has a role, but it's the oceans. Well, makes sense. Oceans cover 71% of the surface area, so we expect that. We find that in response to Arctic sea ice loss, oceans are taking up heat from the atmosphere via sensible and latent heat fluxes, mainly in the subpolar North Atlantic. Okay, keywords mainly. In other words, not exclusively, but mainly. So heat flux uptake is occurring elsewhere. Okay. So, latent heat is basically, if I'm heating up something, if I'm heating up ice, okay, I'm warming it up. That's sensible heat input. When it starts to melt, that's now latent heat. So basically, latent heat is the heat input or removal when you're changing phases. Solid to liquid, liquid to gas, gas to liquid, liquid to solid. Sensible heat is the addition or removal of heat in the middle of a phase. So you already have liquid water that's at say 3C, and you just keep heating it up. Or you have liquid water that's at 15C and cooling it down. That's sensible heat. That's the difference there. So, meanwhile, Arctic sea ice loss induced ocean circulation change could redistribute the taken heat, which, however, is time scale dependent. Makes sense. You need the currents to move the stuff around. Within a decade after Arctic sea ice loss, the Atlantic Meridional Overturning Circulation, AMOC, is little altered. Now, this is a very interesting finding. Within a decade, AMOC is little altered. Not saying there is no alterations to it, but it's little. Now, I say that because there has been a measure of a slowdown, but it hasn't. But it's just doing that. It's slowing down. It hasn't fully stopped. Now, we can talk about the impacts of the stratification of the ocean, such that sequestration of heat and carbon, for that matter, to deep depths, is impaired, is impacted, and we can have that discussion. But within a decade, little alterations, such that result is little alteration that most of the taken heat is locally stored in the Atlantic. However, on a multi-decadal to centennial time scale, AMOC decelerates, redistributing the heat to other basins through interbasin ocean heat exchanges. What that means is, North Atlantic to South Atlantic, South Atlantic to the Indian Ocean, to the Pacific Ocean, to the Southern Ocean, that kind of stuff. Now, very important sentence I want to, this multi-decadal to centennial timescale. Okay, so centennial, hundreds of years. Wally Broker estimated that if you were to follow a parcel of water as the deep water formation forms in the North Atlantic, and follow that through its flows into down to depth, upwelling in the Southern Ocean, traveling into the Indian and Pacific Oceans, returning back to the Gulf of Mexico, back to the North Atlantic, it's approximately 570 years. Approximately. Now, of course, there are other branches that could shorten or lengthen the time scale, but that's the idea of the scale. Wally Broker also showed that slowdown of AMOC to perhaps even complete shutdown of AMOC could take place within decades. So let's go back. Okay. They say AMOC is little altered within a decade, right? Little altered within a decade. But when we go on multi-decadal to centennial timescale, AMOC decelerates. Decelerates, redistributing the heat. In other words, there is a slowdown in sequestration of heat. It slows down moving that heat to depth, which means it also slows down moving that heat to other ocean basins. In other words, within a decade or so, which is what, was how long the AMOC slowdown has been measuring, a decade or two, not much is going on. It's a little altered, but when you extrapolate outwards to, many decades to centuries, then we start seeing great impact. So in other words, in decades from now, centuries from now, we can expect to see a complete shutdown. That's kind of what they're saying here. And so if that heat sequestration to depth slows down, as the conveyor belt basically also slows down, so it would not be able to move that heat around. That's what they're talking about here. When they talk about the deceleration distributing, they're talking a conveyor belt. That big thermohaline flow. They're talking that is basically slowed down to almost a full stop. In the Indo-Pacific Ocean, an anomalous ocean circulation is generated, manifesting an abnormal northward flow near the surface, which imports about 1/3 of the redistributed heat from the Atlantic. And that's via the Southern Ocean into the Indian Ocean. Meanwhile, the Indonesia through flow weakens, giving rise to an anomalous ocean heat transport from the Indian to Pacific Ocean. As a result, both Indian and Pacific Oceans are warmed on a multi-decadal to centennial timescale. The ocean heat update video I just did, that figure I showed you with basically that heat blob occupying basically most of the North Pacific, perhaps that is a harbinger of what they're describing here, or perhaps an early manifestation of what they're describing here. The Arctic sea ice loss also induces a quote-unquote mini global warming with pronounced lower to middle tropospheric warming in the southern hemisphere. In other words, the layer of the atmosphere where weather takes place is warmer. Troposphere. That's what get your clouds and, precipitation, sunshine, that kind of stuff, weather. That's warming. Accordingly, the southern hemisphere westerly winds poleward intensity To modulate the deconsel and residual MOC, this is also overturned circulation in the Southern Ocean. Okay, along with the ocean circulation changes and associated variations in ocean heat transport across the boundary between the Southern Ocean, Atlantic, Indo-Pacific Ocean. 2/3 of the ocean heat imported from the Atlantic remains in the Southern Ocean. It remains there. So perhaps, again, this is on a centennial basis, does not make its way into the Indo-Pacific oceans. So in other words, they're describing several things here. They're describing what happens on a 1 or 2 decade scale. They're describing what happens on a multi-decadal scale, and they're describing on what happens on a centennial scale. That's what they're doing here. And on the 1 or 2 decade scale, AMOC is a little altered. There are some effects, but it's a little altered. You take it on a multi-decadal scale, yeah, it's going to slow down. And that slowdown is going to slow down the heat distribution. So it's on the centennial time scale, during the slowdown, it was moving heat into the Southern Ocean. Then it totally slows down and totally stops. That heat stays in the Southern Ocean. No more. Some of it, which may before gone to the Indo-Pacific Ocean, now it doesn't. So in other words, you're going to start creating major heat gradients within the ocean, both in horizontal and vertical directions. That's what this is. That's what they're basically stating here. So this, of course, has major implications for the climate. And it goes to show you also what a genius Wally Broker was. He was saying this stuff 30, 40, 50 years ago. And basically, they're kind of validating, verifying a lot of the work that he did. So Wally Broker's reach, it cannot be overstated. It is enormous, his reach. From studying the conveyor belt and heat distribution mechanism, as well as using radionuclides, radionuclides to trace movements within the ocean, isotopic fractionation to reconstruct past climate. That's all Wally Broker. It is no small wonder that he is referred to as the grandfather of climate science. I did a video shortly after he passed away, basically in memoriam of Wally Broker. As an oceanographer, he was a giant in the field. And this research here, in a lot of ways, I find it to be an homage to Wally. They're basically validating, verifying what he postulated for all those years. So, basically, expect AMOC to continually to slow down as the decades and centuries ensue, so that as it slows down, the heat distribution will also slow down, such that it may not reach in certain ocean basins when it fully stops, and this will create major gradients, and of course, you have different heat gradients will affect the thermodynamics of basically the climate of the planet, but also that heat moving into the Southern Ocean is warming the troposphere, which is very interesting, showing a flux to the atmosphere. Just like with the loss of sea ice, we have a flux to the atmosphere in the Arctic Ocean. And remember, 93% of the emissions have been taken up by the ocean, 240 zettajoules. That is an awful lot of heat energy in both sensible and latent form that's just waiting to diffuse back to the atmosphere. So there you have it. I say stay tuned, but none of us will probably be alive to see the results. Until next time, thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.